Okay, welcome back. I have written down our three equations that we need. We have one more, of course. We know also that log AT is equal to rho A log AT minus 1 plus epsilon t, but we're not going to use it to get MCT. We're not going to use it to compute the marginal cost. So before I told you you're going to use equation 1, 2, and 3 together to get marginal cost, and let's see how to do it. So right away, you see we have a KT here, we have a KT here, we have an LT here, we have an LT here. Let's put everything together. Okay. Your instinct might have been to put YT here and put YT here, but that leaves you with two equations. And I don't know what to do from there. Maybe you could do some complicated algebra. You should always try to pick the path of least resistance. And in this case, I can put all of these equations together and I can get them down to just one if I go this way, if I plug them here and plug them here. So that should be kind of what you're thinking about. If you're looking at a system of equations on a test, you don't know which way to go. Think about what gets me to the fewest equations possible the fastest. Okay, so we have alpha MCT YT over RT, alpha. And then we have 1 minus alpha MCT YT over WT, 1 minus alpha. Okay, and so you need to know some facts about exponents. Okay, you need to know that you may distribute an exponent over multiplication, right? Just like you can distribute multiplication over addition. Yeah, multiplication is to addition as exponentiation is to multiplication. So I can put this alpha here and I can put this 1 minus alpha here, and then I can bring everything out to the front. So I'll have YT is equal to, I'm going to distribute this alpha into the YT, and then I'm going to pull the YT out. So I'm going to have YT alpha. I do the same thing. I distribute this 1 minus alpha onto the YT, and then I pull it all the way to the front. So YT 1 minus alpha. AT alpha MCT over RT alpha alpha, and then I have 1 minus alpha over WT MCT 1 minus alpha. Okay, and now you can combine the exponents. You know that if you multiply, you add, right? Because my thing. So this is going to be YT to the 1 minus alpha plus alpha. So it's just going to be YT. So I can cancel this and this. So I'm going to get 1 is equal to AT. Now let's do the same thing with MCT, right? Because I have an MCT here, I have an MCT here. I want to get them together. In fact, I'm doing this because I want to know what is MCT. So I need to solve for it. So let's bring that out. So I'm going to do the exact same trick. I'm going to distribute alpha onto MCT, and I'm going to pull it out to the front. MCT alpha. Same thing, distribute 1 minus alpha onto MCT, bring MCT all the way out to the front. MCT 1 minus alpha. My AT is here. I'm going to be left with alpha over RT to the alpha, and 1 minus alpha over WT to the 1 minus alpha. So now we have the same situation. I have 1 minus alpha plus alpha as the exponent on MCT. I just have MCT. So we get 1 over MCT is equal to AT alpha over RT alpha 1 minus alpha over WT to the 1 minus alpha. And we're basically done. We just have to flip this over. So let's do it. We just flip it over. MCT is equal to 1 over alpha t. Now you kind of have a choice. You can choose to write this as minus alpha and keep this the same, right? Or you can choose to flip this. And you probably flip it because it's nice to have positive exponents. You know, alpha is always positive and it's between 0 and 1. So minus alpha is like a negative number. It doesn't make as much intuitive sense. So let's just write it like this. Okay, and we're done. There is MCT. So now we have our equations in our boxes. We have 1, 2, 3, 4, 5. There's one more equation that we pull out, and it comes from the competition structure of the model. And we write down just that firms, this is supposed to be a star, firms are in perfect competition. Thus, And hopefully you know we can write that MCT is equal to the price. Yeah. And this is just a feature of perfect competition. Firms can enter until marginal cost is equal to price and there's no profits. Okay, so now the model's done. And in the next video, we'll sort of gather up all of our equations. We'll double check that we have the same number of equations as variables. And then we'll think about how to proceed. So I'll see you there.